Welcome back to Beyond the Ice, everyone. I'm Chloe, and today we're diving into a topic that truly reshapes our understanding of the planet. With me is Alex, a leading voice in climate science. Alex, it's great to have you here.
Thanks, Chloe. It's always a pleasure to be on the show. The subject we're tackling today, Antarctica's potential shift into a fundamentally new, less icy state, is one of the most profound environmental discussions we can have.
It certainly is. When we talk about Antarctica changing so dramatically, it's not just about a remote continent, is it? We're really looking at something that could trigger a domino effect across the entire globe, impacting everything from sea levels to weather patterns.
Precisely. The implications are far-reaching. A significant change in Antarctica doesn't stay contained. It has the potential to reshape coastlines worldwide and initiate cascading climate changes that affect billions. It's a complex picture, but one we absolutely need to understand.
Precisely. The implications are far-reaching. A significant change in Antarctica doesn't stay contained. It has the potential to reshape coastlines worldwide and initiate cascading climate changes that affect billions. It's a complex picture, but one we absolutely need to understand. Alex, you've highlighted the global impact. Could you elaborate on what scientists mean by a climate tipping point, specifically in the context of Antarctica? What does that term truly signify for the continent's future?
That's a crucial distinction, Chloe. A climate tipping point is essentially a threshold. It's where a relatively small change can trigger a large, abrupt, and often irreversible shift in the entire climate system. For Antarctic sea ice, this means moving from a state with a certain amount of ice to one with significantly less. It's not just a gradual melt, it's a fundamental shift to a new regime that becomes incredibly difficult, if not impossible, to reverse on human timescales.
So it's not just about losing ice, but about entering a completely different state. Are we seeing any evidence that Antarctica might be approaching such a tipping point?
Unfortunately, yes. We've observed record-breaking low sea ice extents in recent years. Think about 2017, 2022, and especially 2023. These aren't just minor fluctuations, they're strong indicators of a potential shift to a new, less icy state.
Those years really stand out. Does this mean we're already past a point of no return for some of these changes, or are we still in a window where action can make a difference?
Well, the Antarctic ice sheet itself reacts very slowly to climate changes. This indicates that the warming effects we're seeing now and the changes they're causing could indeed be irreversible on human timescales. What's happening today will affect generations to come. Even if we were to drastically reduce emissions tomorrow, the system has a lot of inertia.
That's a sobering thought. If we do cross this tipping point, what are some of the immediate or even long-term consequences we should be prepared for globally?
The consequences are profound, Chloe. One major concern is altered ocean currents. As Antarctic ice melts, it dilutes the salty ocean water, which could potentially slow down the Antarctic circumpolar current. That's the world's strongest ocean current, and disrupting it would have global repercussions, affecting everything from marine ecosystems to weather patterns far from the poles.
And sea level rise is another major concern, I imagine, directly linked to the melting ice?
Absolutely. The melting of the Antarctic ice sheet directly contributes to significant sea level rise, which would impact coastlines and communities worldwide. It's not just a regional issue, it's a global threat to coastal infrastructure and populations.
It sounds like these changes in Antarctica don't just stay contained within the continent. They truly have a ripple effect across the entire planet.
They certainly do. Shifts in Antarctica's sea ice cover and its massive ice sheets have far-reaching consequences for the entire planet. It's a connected system, and what happens at one pole affects the other, and everything in between.
Given this potential for irreversible changes and cascading effects, what's the urgency in understanding all of this now, for us, for future generations?
It's critical because these impacts will affect future generations directly. We're talking about human-relevant timescales here, not geological ones. Plus, the complex interactions between the atmosphere, ice, and ocean mean one tipping point could trigger another. This uncertainty increases the risk, necessitating a precautionary approach to climate change. We need to understand these dynamics to make informed decisions and mitigate the worst outcomes.
That really underscores the importance of our discussion today. We're not just observing, we're trying to understand a system on the brink of fundamental change.
Exactly, Chloe. And when we talk about a system on the brink, it's crucial to understand the domino effect you mentioned earlier. It's not just one isolated event.
Right. So, Alex, let's dive deeper into that. How does a change in one part of Antarctica, say the melting sea ice, actually trigger a cascade of other changes, both locally and globally?
Well, it starts with the fundamental properties of water and ice. When sea ice melts, it introduces fresh water into the ocean. This fresh water is less dense than the salty ocean water, and it can stratify the water column. This stratification can then interfere with the deep ocean circulation, particularly the Antarctic circumpolar current, which is a massive driver of global ocean systems.
So, it's not just about the physical melting, but how that melt fundamentally alters the ocean's dynamics and its ability to circulate?
Precisely. If the Antarctic circumpolar current slows down, it's not just a regional issue. This current plays a vital role in distributing heat and nutrients around the world's oceans. A disruption there could lead to altered marine ecosystems, changes in global weather patterns, and even impact fisheries far from Antarctica.
That's a significant ripple effect. And what about feedback loops? Does the initial melting accelerate further melting, creating a self-reinforcing cycle?
Absolutely. That's a key part of the domino effect. When sea ice melts, it exposes darker ocean water beneath. Ice is highly reflective, bouncing sunlight back into space. But the darker ocean absorbs more solar radiation, which in turn warms the water, leading to even more ice melt. It's a classic positive feedback loop, accelerating the warming trend.
So, less ice means more heat absorbed, which means even less ice. It sounds like a runaway train once it gets going.
It can certainly feel that way, and this isn't just about sea ice. The melting of the massive Antarctic ice sheet itself contributes directly to global sea level rise. But the interaction between the ice sheet, the surrounding ocean, and the atmosphere is incredibly complex, making it difficult to predict the exact timing and magnitude of these cascading events.
This interconnectedness sounds incredibly complex. Are there specific examples of how a change in Antarctica might directly impact, say, weather patterns in other parts of the world?
Well, changes in ocean temperatures and currents originating from Antarctica can influence atmospheric circulation patterns. This might shift storm tracks or alter precipitation regimes in distant regions. It's a bit like a butterfly effect, but on a planetary scale, where a change in one major component of the climate system can have far-reaching, sometimes unexpected consequences.
It sounds like the uncertainty itself is a major challenge. How do scientists model these cascading effects, especially when they involve so many interacting systems?
It's incredibly challenging. We use sophisticated climate models that try to simulate these interactions, but the sheer scale and complexity mean there are still significant uncertainties. That's why the concept of a precautionary approach is so vital. Given the potential for irreversible changes and cascading tipping points, we need to act with caution and urgency.
So it's about understanding that even if we don't have every single detail mapped out, the risk of these domino effects is high enough to warrant immediate and significant action.
Exactly. The potential for one tipping point to trigger another, creating a chain reaction, is a serious concern. We're talking about fundamental shifts in Earth's climate system that would affect generations.
It really brings home the idea that Antarctica isn't just a distant frozen landmass, but a critical component of our global climate engine. We've touched on the immense power of the Antarctic circumpolar current, Alex, and how its disruption could ripple globally. But let's really zero in on sea level rise. How does the melting of the Antarctic ice sheet specifically contribute to this? And what does significant really mean for us?
That's a critical distinction, Chloe. When we talk about sea level rise from Antarctica, we're primarily concerned with the massive land-based ice sheet, not just the sea ice. Sea ice, is already floating, so when it melts, it doesn't significantly add to ocean volume. However, the Antarctic ice sheet holds an enormous amount of water that's currently locked up on land. As that ice melts and flows into the ocean, it directly increases the total volume of water, leading to a rise in global sea levels.
So it's the sheer volume of ice on land that's the primary concern here. What kind of scale are we talking about? When you say significant, what does that translate to in terms of actual sea level increase?
Well, the Antarctica ice sheet contains enough ice to raise global sea levels by many tens of meters if it were all to melt. Of course, that's a very long-term scenario, but even a fraction of that melting over centuries would be catastrophic. In the shorter term, even a few feet of global sea level rise, which is certainly within the realm of possibility this century, would have profound impacts on coastal regions worldwide.
A few feet sounds manageable to some, but I imagine the reality for coastal communities is far more complex than just a simple rise in water level.
It absolutely is. It's not just about the average water level. Higher sea levels mean more frequent and severe coastal flooding during storms and high tides. It leads to increased erosion, saltwater intrusion into freshwater aquifers, and damage to vital infrastructure.
So it's not just about losing beachfront property, but about the fundamental livability and economic viability of entire coastal cities and agricultural areas?
Precisely. Think about major port cities, low-lying island nations, or even agricultural lands near the coast. They become increasingly vulnerable. Infrastructure like roads, sewage systems, and power plants are often built at elevations that simply won't be viable with higher sea levels.
And these changes, as we discussed earlier, are largely irreversible on human timescales. That means the decisions we make now, or fail to make, will lock in these consequences for generations.
That's the sobering truth. The ice sheet responds slowly, but once it starts to melt significantly, it's incredibly difficult to stop or reverse. The impacts of sea level rise will affect our children and grandchildren, shaping their world in profound ways.
It really highlights the intergenerational aspect of this crisis. Are there particular regions or types of communities that are most at risk from this projected sea level rise?
Absolutely. Low-lying coastal areas, deltas, and small island developing states are particularly vulnerable. But even major cities like New York, Miami, Shanghai, or Mumbai face immense challenges in adapting their infrastructure and protecting their populations.
It sounds like a global challenge that requires a global response, especially given the far-reaching consequences you've outlined.
Indeed, the melting of the Antarctic ice sheet is a global issue with local impacts everywhere.